Hi everyone. Today we're going to be beginning our first notes in Chapter 7 on analytic geometry with 7.1 Discovering the Pythagorean Identities. I want to start with a review. Let's review the reciprocal properties. We know that the reciprocal of sine is 1 over the sine, or the cosecant of x. We know that the reciprocal of cosine, or 1 over cosine, is the secant of x, and the reciprocal of tangent is the cotangent of x. Therefore, it follows that the cosecant of x is simply the reciprocal of the sine. The secant of x is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. Okay, these are the definitions for the reciprocal functions. Therefore, if we have some expressions like sine x times cosecant of x, we can simplify this, right? We know that sine x is, well, let's just call that sine x. But then cosecant x we can rewrite as the reciprocal of sine, or 1 over sine. Therefore, sine x times 1 over sine x is just 1. Okay, those sine x's cancel out. Then we have cosine x times secant x. The same follows. So we have cosine x times the reciprocal of cosine. And something times its reciprocal is just 1. And finally, tangent times cotangent. Well, we know that, the reciprocal of tangent is the cotangent. So we have tangent times 1 over the tangent. And again, anything times its reciprocal is just 1. Now let's talk about the quotient properties. Now tangent of x, yes, we can represent it as the reciprocal of cotangent. However, there's another way that we can represent this. When we did our unit circle unit, we talked about tangent as being the ratio of the vertical component and the horizontal component, right? The opposite over adjacent, or y over x. The same is true for these trig ratios. We would say that like sine corresponds with y and cosine corresponds with x. It's true that that trigonometric ratio holds here as well, that the tangent of x is equal to the sine x over cosine x. Okay? So it follows that the cotangent of x, the reciprocal of tangent, would just be the reciprocal of that ratio, cosine x over sine x. And that is true as well. So let's use these two properties to simplify each of these expressions. For part A, I have the secant of x over the tangent of x. I can rewrite each of these in terms of sine and cosine. So secant of x would be 1 over the cosine of x. And tangent of x is sine x over cosine x. We just learned that. Well, dividing by a fraction is the same as multiplying by its reciprocal. So we have 1 over cosine x times the reciprocal cosine x over sine x. Okay? When we multiply this, our cosines cancel out. We get 1 over the sine, or just the cosecant. Okay? Part B, we have cotangent, cosine, sine. Let's rewrite cotangent in terms of sine and cosine. So we have cosine x over sine, and this is times the cosine and times the sine. All right? Well, the sine and cosine I can just put over 1, right? So we have a sine in the numerator and a sine in the denominator, so these cancel out. We're just left with the cosine of x times itself, or the cosine of x squared. Another way that we can write this, which is how you're mostly going to see this, is cosine squared of x. So that's saying we're not squaring x, we are squaring the cosine of x, that function. Okay? So this reads as the cosine squared of x. Part C, we have cosecant x tangent x. So let's rewrite this in terms of sine and cosine. Cosecant is 1 over the sine, and tangent is sine over cosine. Okay? Again, we have a sine in the numerator, sine in the denominator. So we're left with just 1 over the cosine. And let's flip that back to the reciprocal. So we have just secant of x. And part D, we have secant x, cotangent x, sine of x. Again, let's rewrite this in terms of sine and cosine. We have 1 over the cosine times the cotangent, which is cosine x over sine x. And then we have times sine x. Okay? Well, we have cosines in numerator and denominator, so we can cancel those out. Likewise, we have sines in both the numerator and denominator. So we're just left with 1 over 1 or 1. Okay? Now let's talk about identities. An identity is an equation that is valid for all values of the variable for which the expressions in the equation are defined. You should already be familiar with some identities. So for example, a difference of squares, x squared minus y squared, This is true for its factorization, x plus y, the quantity, times the quantity x minus y. This is true for all values x and y. So that's an example of an identity. In this figure below, when we talk about the unit circle, well, actually before the unit circle, say this is some point on a circle with radius c, we can define this triangle by dropping a perpendicular to the x-axis, and we get a vertical component b and a horizontal component a. Therefore, the ratio, the cosine, that trigonometric ratio, is equal to the adjacent over the hypotenuse. Remember SOHCAHTOA. So the adjacent side is a, the hypotenuse is c, so the ratio is a over c. Likewise for sine, SOHCAHTOA, we have opposite over hypotenuse, or b over c. Okay? We can also, because this is a right triangle, we dropped a perpendicular, we can use the Pythagorean theorem to describe the relationship that exists between the side lengths. And we know the Pythagorean theorem is the sum of legs squared is equal to the hypotenuse squared, or a squared plus b squared equals c squared. Okay? Now let's consider where the radius is 1. So that c value, the hypotenuse here, is 1. Let's see what this would look like. If I were to just choose some values theta, and then evaluate the sine and cosine of each, and then square it, and then take its sum, what would I expect it to be equal to? Well, let's see. Let's choose some values. So in quadrant 1, let's choose, say, 30 degrees. If I were to take the sine squared of 30 degrees, we first have to evaluate sine of 30 degrees. Well, sine of 30 degrees is 1/2, and if we square it, then that would be equal to 1 squared over 2 squared, or 1/4. The cosine of 30 degrees, well, we know the cosine of 30 degrees is the square root of 3 over 2. If we square that, we get 3 over 4. Okay? If we take the sum of those squares, we get 1/4 plus 3/4. That's equal to 1. We have 4/4. Quadrant 2, let's try, say, 135 degrees. Well, the sine of 135 is equal to positive root 2 over 2. If we were to square that, we would get 2 over 4, or 1/2. The cosine of 135 is negative root 2 over 2. And if we were to square that, we would get the same, positive 2/4, or 1/2. So then if we take the sum of those squares, we have 1/2 plus 1/2, we get 1. You may be starting to see a pattern. If I were to choose an angle in quadrant 3, say 240, well then the sine of 240 is equal to the negative root 3 over 2. Let's square it. We get positive 3/4. And then the cosine is going to be negative 1/2. So cosine of 240. We square it, and we get positive 1/4. Remember that squaring gets rid of that negative. So therefore, the sum is 3/4 plus 1/4. And we know what that is. That's equal to 1. And let's try one more just for good measure in quadrant 4. Let's do, say, 300 degrees. Okay. The sine of 300 degrees is negative 1/2. I'm sorry, it's negative root 3 over 2. There we go. And if we square that, that's equal to positive 3/4. And then the cosine is positive 1/2. If we square it, that is equal to 1/4. So then the sum, 3/4 plus 1/4, is equal to 1. And so we've tried this for four values theta from 0 to 360, and it's been, the sum of the squares has been 1 every single time. This isn't a coincidence. This is true for all values theta. Therefore, it gives us another identity. Sine squared of theta plus cosine squared of theta is equal to 1 for all theta. So here's our identity here. Okay, we call this, in trig, we call this the Pythagorean identity. Okay. We have two more Pythagorean identities, and they're derived from this first one. In order to make these, we need to recall the definitions of the other four trigonometric functions outlined in our warm-up. So, okay, the first one, we're going to divide both sides of the Pythagorean identity by this cosine squared and then simplify. So let's go ahead and rewrite. We have sine squared plus cosine squared equals 1. Oh, and before we move on, actually, I just want to point out, remember sine corresponds with y and cosine corresponds with x. You can think of this, in your mind, I like to think of this as, I'm going to flip these around, x squared plus y squared equals 1, or 1 squared, right? When we're looking at the unit circle, we have our horizontal component and our vertical component. On the unit circle, if the radius is 1, then we have the Pythagorean theorem here, right? X squared plus y squared equals 1. Well, cosine corresponds with x, sine corresponds with y on the unit circle, and then we have equals our hypotenuse squared. So it follows from our triangles as well, geometrically. Okay, so back to part A. Divide both sides by cosine squared. Okay, so I'm going to divide this whole side by cosine squared, and I'm going to divide this side by cosine squared. Okay? What I get is this first term here, sine squared divided by cosine squared, is the tangent squared. Remember, tangent is the ratio of sine over cosine. This second term here, we got to divide as well. Cosine squared divided by cosine squared is just itself 1. And then we have 1 over the cosine squared is the secant squared. Okay, so we get another Pythagorean identity here. Tangent squared plus 1 is equal to the secant squared. And let's see what happens when we divide both sides by sine squared. So if I have sine squared of theta plus cosine squared equals 1, that's our original Pythagorean identity. We divide both sides by sine squared. Then this first term, sine squared divided by sine squared, is 1. Cosine squared divided by sine squared is the cotangent squared. And then 1 over the sine squared is the cosecant squared. So another Pythagorean identity, we have 1 plus cotangent squared equals the cosecant squared. Okay? So in summary, here are 3 Pythagorean identities. Other forms of these is if we move around some of these terms. So this very first one, cosine squared plus sine squared equals 1. If I were to subtract sine squared from both sides, then I would get cosine squared of x, we're using x now, is equal to 1 minus the sine squared. So this is another form that you could see this Pythagorean identity. If I were to subtract cosine squared, I would get sine squared of x is equal to 1 minus the cosine squared of x. So just as it's important to recognize this first identity, it's equally important to recognize these other 2 identities as well. Let's see what this looks like for the other, the tangent and secant one and the cotangent cosecant one. Okay, so if we subtract tangent squared from both sides, we get 1 is equal to the secant squared of x minus the tangent squared of x. And if we subtract 1 from both sides, we get tangent squared of x is equal to secant squared minus 1. For the last one, if we subtract 1 from both sides, we get cotangent is equal to cosecant minus 1. And then if we subtract cotangent from both sides, we get 1 is equal to the cosecant squared minus the cotangent squared. Okay? So you should be familiar with, for sure, these 3 forms, but then also any of the other forms that these 3 might show up in. Okay? Moving around some of those terms. Okay, so this brings us to simplifying trigonometric expressions. So we're going to have these expressions, and we're going to have to simplify them using our identities, be it the reciprocal property, the quotient property, or the Pythagorean identities. Some strategies for these is we want to convert things to sine and cosine. So like anytime we have secant, cosecant, tangent, or cotangent, we can rewrite them in terms of sine and cosine. Often we'll find that it'll cancel out some quantities. Factoring is always a good strategy. We can start to factor and see if we get any of those identities. Combining fractions to get a common denominator is going to reduce the number of terms. Okay, when we reduce terms, sometimes some things cancel out. We'll see a few examples of those. And then finally, we're looking for those identities, again, reciprocal, quotient, and Pythagorean. Okay, so let's start with letter A. We have sine t, cotangent t. I'm going to rewrite the cotangent in terms of sine and cosine. So we have sine t times the cotangent, which is cosine t over the sine t. And we have a sine in the numerator, sine in the denominator. They cancel out, and we're just left with cosine of t. So this simplifies to just the cosine of t. Letter B, we have cosine x times the quantity secant x plus cosecant x cotangent x. I'm going to rewrite this in terms of sine and cosine. So we have cosine x times secant is rewritten as 1 over the cosine. Cosecant is 1 over the sine. And cotangent is cosine x over sine x. Okay. Now let's go ahead and distribute this cosine into this grouping. We have in this first term, cosine x over cosine x, that's just 1. And then we have 1 times cosine x, that's cosine squared. And then in the denominator, we have sine squared of x. Okay. Cosine x, cosine squared over sine squared is equal to the cotangent squared. So we have 1 plus cotangent squared. And this looks like one of our identities. This is equal to the cosecant squared. Okay? Part C. Here we have secant squared minus tangent squared all over cosine. Well, I know the secant squared minus tangent squared. That's one of our identities. That's equal to 1 over the cosine. And that's just one of our reciprocal functions, the secant of x. Part D, we have cosine cubed of x, sine squared plus sine squared of x, cosine of x. I'm going to go ahead and factor out a cosine of x, and we're left with cosine squared plus the sine squared. And right there, I see another Pythagorean identity. This is equal to 1. So we have cosine x times 1, or just the cosine x. All right. Go ahead and flip the page. Part E, we have the cotangent squared over cosecant x. I'm going to rewrite cotangent squared as cosine squared over sine squared. And then cosecant, I'm also going to rewrite as 1 over the sine. Okay. By the way, I like to make my fraction bars nice and big so that I know which quantity is being divided by which. It helps me organize my division here. Okay, so because I'm dividing by a fraction, we can multiply by the reciprocal. So cosine squared x over sine squared x times the reciprocal sine x over 1. I'm going to cancel out one of these signs. We have 2 in the denominator, 1 in the numerator. So we have cosine squared x over 1 sine is left over. Okay? So we have 2 cosines up top, 1 sine in the bottom. We can combine one of those cosines and sines into the cotangent. And then there's 1 cosine left up top. So we have cotangent x, cosine x. Letter F. I notice that we've got 3's in front of these. This kind of looks like one of the Pythagorean identities, but we've got 3's in front. So I'm actually going to group these and factor out that 3. That way I can deal with that Pythagorean identity. So I have 3 times the quantity cosine x, cosine squared plus sine squared. And then on the outside of that grouping, we have minus 1. Well, this is our Pythagorean identity. So this is equal to 3 times 1, which is 3. And then 3 minus 1 is 2. All right. Part G, we have sine over cosine plus cosine over 1 plus sine. All right. So for this here, I noticed that we could rewrite this in terms of tangent, sine over cosine, but instead everything's already written in terms of sine and cosine. So strategy that we can use here, I can't cancel anything out here. I could find a common denominator, but I noticed that this denominator here is, it's got 2 terms here. We've got 1 plus the sine. A strategy that we can use is called multiplying by the conjugate. So instead of multiplying by itself, 1 plus sine theta, we're going to multiply this by 1 minus sine theta over 1 minus sine theta. And I don't want to change this problem. Notice that I'm just multiplying by a clever form of 1, something over itself. So I'm not changing the problem, but notice what happens to our denominator. In fact, you might already recognize this as the difference of squares, the other identity that we talked about earlier. Okay? So if I bring this down, we have sine theta over cosine theta. And then this other term, so plus, we have cosine of theta times this grouping. I'm actually not going to multiply this out quite yet. But I noticed that in the denominator, we've got a difference of squares. 1 squared minus sine squared. Okay, if we were to multiply this out. Now, this gives us one of our Pythagorean identities. 1 minus sine squared is equal to the cosine squared. So we have sine over cosine plus the cosine times 1 minus the sine. And that's over the cosine squared. Now, notice what happens here. We can cancel out one of these cosines. Okay, and then we finally have a common denominator between both these terms. So we have sine of theta plus 1 minus the sine of theta. I'm dropping these parentheses over the common denominator cosine theta. Okay, so we have our sine theta and our minus sine theta cancel out in the numerator, and we're just left with 1 over the cosine, which we know to be secant. All right, so this whole thing reduced to just the secant of theta. Letter H, I'm going to rewrite this in terms of sine and cosine. So we have sine x plus the cotangent, which is cosine of x over sine of x, and then cosine of x. And this is all over the cotangent, which is cosine x over sine x. Before we move on, one thing I want to just point out is you cannot cancel out these cotangents because we have this addition right here. So just be very careful when you're doing this problem, okay? Just notice you can cancel out factors, not terms. Okay, so now we're dividing by a fraction. Actually, let me go ahead and simplify the numerator. So we have, if I want a common denominator of sine of x, we're going to multiply this first term by sine x over sine x. So we get sine squared x, and then we have our plus cosine squared x, and that's all over sine of x, and that's all over the cotangent, or cosine x over sine x. Okay? Well, on the numerator, I notice that we have 1 over the sine x. So this is equal to, I'm just going to write this as 1 over sine x. And then we're dividing by a fraction, so let's multiply by that reciprocal. Okay? We have a sine in the numerator, sine in the denominator. This is equal to the secant of x. Okay, so again, this whole thing reduces to secant of x. All right, so we got 2 more for us today. We have cosine of theta over the secant of theta minus tangent of theta. Let's rewrite this in terms of sine and cosine. So cosine of theta over 1 over cosine theta minus sine theta over cosine theta. Okay? In the denominator, we need a common denominator because we got these subtraction of fractions. So we have cosine theta in the top. And then in the denominator, we already have a common denominator. So we have 1 minus the sine of theta over cosine of theta. Okay? Dividing by a fraction is the same as multiplying by the reciprocal. So we have cosine over 1 minus the sine. And then we have the cosine squared of theta over 1 minus the sine of theta. Okay, we're not done yet. We can use the same technique that we did earlier, multiplying by the conjugate. So we have 1 plus the sine of theta over 1 plus the sine of theta. And again, we're not changing the problem, just multiplying by a clever form of 1. So we have cosine squared of theta plus the sine of theta. Cosine sine of theta. So I can go ahead and add that on. Because we got to distribute it to that whole grouping. Cosine squared, there we go. And then we have a difference of squares, so 1 minus the sine squared. Okay? And we know that 1 minus the sine squared is equal to the cosine squared. So this is equal to cosine squared of theta plus sine of theta, cosine squared of theta, all over cosine squared of theta. We can cancel out these cosines, all 3 of them. So the cosine divides out into every single term here. And we're just left with 1 plus the sine of theta. I suppose you didn't have to distribute earlier. I guess you could have just left it out as cosine squared times the quantity 1 plus sine squared. That's fine. Either way works. And let's go ahead and do the last one. So we have cotangent plus tangent. I'm going to rewrite this in terms of sine and cosine. So we have cosine theta over sine theta plus sine theta over cosine theta. Common denominator. We have to multiply the left-hand side by the cosine over cosine. So we get cosine squared. The right-hand side we have to multiply by sine over sine. So we get sine squared. And this is over common denominator, sine theta, cosine theta. Well, we got our Pythagorean identity. So cosine squared plus sine squared is equal to 1 over sine cosine. And this is equal to the cosecant secant. All right. All right, so as a reminder, we've got our identities, right? Our reciprocals. All of our reciprocals can be rewritten into in terms of sine and cosine. Our tangent is sine over cosine. Cotangent is cosine over sine. And then we've got our Pythagorean identities, right? Cosine squared plus sine squared equals 1. We've got 1 plus the tangent squared is equal to the secant squared, and cotangent squared plus 1 is equal to the cosecant squared. Okay? We're going to get a lot of practice on this, so we'll see you tomorrow. Have a great day, everybody. Goodbye.